Section 3.1 is called Numeration Systems. And we're going to cover a variety of things in this section. The first thing that we're going to take a look at is some sort of historical development of some things. Before we go back too far, we're just going to define something that you already know, but you probably didn't know it was called this. The Hindu-Arabic numeration system. This is actually the numeration system that we use today. Okay? It was developed by the Hindus and transported to Europe by the Arabic. In our number system, some features, again, that you already know is that all numerals are constructed from digits that are 10 digits. So what are our 10 digits? What's the first one?
0.
It is 0. And what is our largest one? It's actually 9. So when we talk about digits, we're talking about the single values. So 10 is not a digit, okay? 10 is 2 digits long. It's a 2-digit number. Our place values are based on powers of 10 as well. So in other words, we have, these different, I'll put lines for them for a second here. This is the ones place and this is the tens place, right? And then we have the hundreds place, but 100 really is just 10 squared. And then we have the thousands place, and 1,000 is actually 10 cubed. So that's what that's referring to. So our place values are based on powers of 10. And the reason it's powers of 10 is because we have a base 10 system. So any guesses as to why we might have a base 10 system? Any thoughts? Why do we have 10 digits? Why do we have a base 10 system?
10 is a simple number?
It's a what number?
Simple?
No, because like 5 is 2 or 8 is. So what's special about 10 that 5 and 8 don't have per se? No thoughts? It's okay. It's because of this. How many little appendages on the end of your hands do you have? 10, right? So what if God had made us without thumbs? What system would we probably use? We probably use base 8, okay? So we use base 10 because of the counting issues with 10 on our fingers. You're going to see that not all, historically, not all cultures have used base 10. And we'll talk a little bit when we encounter each one of them, what they might have used and maybe why they might have used it. But the basic reason why we use 10 is because we have 10 fingers, okay? All right, so one more thing in this is to remember what exponent notation is. If we have a power of n like this, a raised to the n power, it means we have a multiplied by itself n times. Okay. So just a little bit of notation that we're going to end up using as we take a look at these other number systems. All right, you ready to take a look at the first one? Okay. The first one is the Egyptians, and I'll let you fill this in first, and then I have something to show you, a physical object actually. These are the different base numbers, or numerals rather, in the Egyptian system. So the first one you'll just look at a tally mark, right? Or like our digit 1. The second one is an upside down U. They call it a heel bone. You can kind of imagine why they would call it that, right? This next one is called a scroll. And it looks a little bit like our number 9, a little bit, not a lot, but a little bit. The next one is the one that I probably draw the least well. I'm not even sure if you say least well. I don't draw this well at all. It's a lotus flower, and if you look in your book, they'll probably have a much better picture for you to emulate than mine. The next one is supposed to be a pointing finger. Also, I don't draw well, just in general, just so you know. That's a pointing finger. The next one is a pollywog. Sometimes you'll hear it described as a whale or a fish or a burbo fish, something like that. It's supposed to look like a tadpole or like a fish. Use your imaginations, right? Pretend, just for the moment. And this last one is an astonished man. And depending on the resources, I've seen it drawn a couple of different ways. This is the way your book draws it, but I've also seen it drawn like this. So his legs look a little bit different. I don't know that it really matters, but just to be aware that some of these are not really universal images that we see all the time. They're a little bit more creative because they're pictures, okay? I wanted to go with you through this and tell you what the values are for each one of these. All right, so what would you guess that first value might be worth? Just guessing. It is. It's actually worth the value 1. A heel bone is actually worth the value 10. A scroll is worth the value 100. A lotus flower is worth the value 1,000. Do you see a pattern? What would we do for pointing finger? It is 10,000. The pollywog? It's 100,000. And then I believe that the astonished man is astonished because he's worth 1,000,000. I mean, if I were worth 1,000,000, I would be astonished. How about you? That'd be pretty cool. So it's worth 1,000,000. Their numeration system is actually very easy to use in terms of it's easy to write down, it's easy to read it and whatever, but it's not terribly efficient, okay? So let me start first by sending around a piece of jewelry that I own. This is it's very tarnished, so ignore that part of it, I guess. But this is actually Egyptian numeration for my name. So my name is on one side. My mother got this for me when I was younger, and then it's got the Egyptian symbols for my name on the other side. So I just think it's kind of cool. Of course, they use their images not just for numbers, but you guys can take a look at that in terms of letters as well. And it doesn't correspond like this is a K and this is an A like that. It doesn't do quite like that, but you can get kind of a picture of that. All right, so let me show you a little bit about how their number system works. What they do in their number system is they repeat symbols for however many symbols they want. For example, or for how many value they want. For example, on this one, what you'll notice is there are 3 scrolls. How much is a scroll worth? 100. So what do you think 3 scrolls is worth? 300. Okay, I mean, that's just how it is. They just repeat the symbol so that they get another 100 or another 1,000 or whatever. So you see a lot of repeating symbols. If they don't have anything, they just don't include it. Like, for instance, on this one, there's no vertical staff at the end, right? Well, it just means there's no ones. No big deal. They just don't write it. Okay? So let's take a look, and we'll do the questions in order because I don't want you to think that every single time you need to turn this into one of our numbers to answer the other questions, because you don't. Sometimes they'll ask you to turn this into our digits, and sometimes they won't. So think with me for a moment on this one. This one says, what Egyptian numeral comes before this value? So we already said that basically these are hundreds place. What is this the place value of? It's the tens place, okay? So if you're thinking about what will come before this value, what's going to be affected or changed? The last digit, right? And in general, that's the way it works with all numeration systems, is we look at the last digit to figure out what happens when we increase or decrease something. So if I'm going to look at what comes before this one, how would I change that last value, that last numeral, that heel bone? Yeah, I would want that basically 10 to be the number 9. So I'm still going to have my 3 scrolls, but instead of a heel bone, I'm going to have, go ahead and say it, Kaylee. The vertical staff, and I'm going to have 9 of them, right? So this would be the number that comes before the first value that I was given in Egyptian numerals. What would be the number that comes after? Yeah, you just include an extra staff, right? So originally I had the 3 scrolls and a heel bone, and I just want 1 more, so I can include an additional staff to doing that. So the number that comes after on this one is actually easier to process than the one that comes before, because the one that comes before includes changing something and incorporating a whole lot of something else. Let's actually write this number in Hindu Arabic numeration system. We've already kind of talked about it a little bit. There are 3 scrolls, and I'm going to write this out just to be real detailed. You don't have to write these details out. How much was the scroll worth? 100. So there's basically 3 times 100 here. And then there's 1 heel bone, and how much is the heel bone worth? 10. So what is this number? It's 310. The reason I'm writing it like this is because we're about to see that this becomes much more complicated when you're not dealing with Babylonians. When you're not dealing with Egyptians. Once we start looking at Babylonians and Mayans, things look really funny, but they all have the ability to be rewritten in this sort of a fashion that we can then turn into the whole number digit at the bottom. Okay? All right, we're going to do one more about Egyptians before we leave them. We have the value 23,145. Do you have that one in your notes? Is that one on the next page, maybe? Okay, great. And what we're going to do is we're going to write that numeral, that's our numeral, in their system. Okay? And again, this is really clean and simple, even if it is like long and drawn out. It's very clean and simple in Egyptian. What would I do to get that first 2? All right, so I need something that's worth that place value, and in that place value is the 10,000s place. And their 10,000s place for the place value is a pointing finger. So I need 2 pointing fingers. What would I do to get the 3? Yeah, I need the next value, right, which is the thousands place value. And in the thousands place, they drew a lotus flower. So we've got 3 lotus flowers. I'm sure your lotus flowers will all be much prettier than mine. What about the next one, the 1? There's a scroll there, and I just have one of them because it's the number 1. How about the 4? 4 heel bones. And the 5? 5 staffs. One other caveat, just to be aware, especially if you're like looking in the back of the book, if they have more than about 6-ish numerals, sometimes they stack them. Like for instance, let's say I had 67 as my numeral. They might write 3 of these stacked on top of each other for 6, like that, and then do something similar with their 1s. So they might sort of do some sort of stacking. Stack, don't stack, I don't really care. But just be aware that they might actually do that, okay? Any questions on Egyptians? Okay, so their system is easy to use, but it's not very practical, right? Especially if you happen to have lots of big numbers in our numeration system. If you have lots of 8s and 9s and 7s, this would take up a lot of paper, wouldn't it? Not real practical. All right, so let's take a look at another numeration system. These are the Babylonians. Their number system has one nice thing, that it's only got 2 numerals. All right, they've got this triangle, kind of looks like what we would call an upside-down triangle. And then they have this one that looks sort of like an arrow going left. Now, practically speaking, as you're writing these, I'm okay with you drawing this empty. You don't have to shade it in, okay? And I'm really okay with you writing this like a less than sign. All right, that's distinctive enough. It's close enough to what they're using. I'll know what you're talking about if you use it, okay? We need to talk about value, the value of each one of these symbols. All right, the first one has the value 1. You'll find in almost all our systems, maybe all of them, yeah, there is a value for 1. So this is our 1 value. And the second one actually has the value 10. Now, all of a sudden, you should be like, okay, that doesn't sound like enough values. Like, what am I going to do if I have the number 2,468? I'm like, that's not helpful. Well, think about it, actually. We only have 10 values, but if we only use the values one at a time, if we wanted to write out the number 150, we really wouldn't want to write out like 5555555, like duplicate the digits, kind of like the Egyptians did. We wouldn't want to do that. So what do? Well, we have something called a place value system, and so did the Babylonians. So their place value system, our place value system is a base 10. So each of my place values had like a 1s place, and then I had 10, and then I had 10 squared, right? Well, they have a base 60 system. So they have the 1s place, but then instead of the 10s place, they have the 60s place. Instead of 10 squared, they have 60 squared. And 60 squared is 3,600, just to keep everybody on the up and up. Okay. So their place values are a little bit different. Okay. So you've got an example next of a numeral that they have. And again, we could do some stacking with their numerals as well. But let's actually take a look at their numeral and think about how we interpret it and see what they're doing with the place value business going on. So here's their numeral here. And I think that my screen matches yours. So let's double check to be sure. You should have 1 triangle at the beginning, do you? Okay, how many of the arrow shapes do you have right here? 5. So I'm just going to jot the 5 down to remind ourselves. And then how many triangles do you have at the end? 9. Excellent. Okay, now in their place value system, the larger value always comes before the smaller one. So which one of these values are larger? Is it the arrow or is it the triangle? The arrow is worth more. It's worth 10 instead of being worth 1, right? So their larger value comes before the smaller one, means that this is the natural breaking point between place values. Because if you notice, on the left-hand side of it, that value's smaller, isn't it? And I wouldn't put the smaller value in front unless it was in another place value system. Or another place value. I said that funny, but another place. So in other words, this is the 1s place. and this over here is the 60s place. Okay? So think about for us, when we put the number 558, that 5 doesn't mean 5, right? It means 5 what? Think money for a sec. 5 what? 5 tens, right? I mean, think actual physical dollars. That's 5 $10 bills, right? It means 5 tens. So this number right here is the number 1, but it's not the number 1. It's the number 1 in the 60s place. Just like this is the number 5 in the tens place. It means 5 tens. Well, this means 1 60s. So imagine having some kind of a money system where you didn't have a $1 bill, or sorry, you didn't have a $5 bill and a $10 bill. You had the $1 bill and then you had a $60 bill. That's kind of the idea of what we're looking at here. Okay? Now before we actually, I think it's on the next slide, isn't it? Yeah, there's another slide that actually tells us that we're going to change the values around. We're actually going to answer the questions of what comes before and what comes after first, though. Okay? So the first question that we're being asked is the Babylonian numeral that comes before this place value. So what would I have to do to get the value that comes before this? What do you think? Right. One of the triangles in the ones place that's on the far right-hand side, one of those triangles is worth 1, right? So if I want 1 less, I just take 1 away. It's just taking one object away. Okay, so the first question that we're going to fill in means that I'm going to have the first triangle stays the same. I'm going to have the 5 arrows. Mine look like less than signs. And then instead of having 9 triangles at the end, we're going to have 8. And that actually answers the first question. Didn't turn it into anything different. It just answered the question. What would I have to do to get the one after? If I... Yeah. All right, so if I take 1 away for part A, I would add 1 for part B, right? But if I add 1 for part B, that gives me 10 triangles. How much is 10 triangles worth? An arrow. Okay, but let's slow down. How many arrows would that give me then? 60 arrows.
So you put 1 other triangle in the 60s.
Right. Yeah.
Would you consider 1?
So we already had 1 triangle from before. And we're going to have 1 more triangle because we're going to take the 10 triangles and turn them into an arrow. Then we're going to take the 6 arrows and turn them into a bigger sized triangle, quote unquote. It doesn't look any bigger, but a bigger place valued sized triangle. And Madison notices there's a problem with this, don't you think?
Because then that could just be kind of as 2.
Right. That's question number 3. How else could that value from part B interpreted, be interpreted? It could be interpreted as the number 2, couldn't it? That's kind of a problem, don't you think? If you meant you had 2 $60 bills and someone thinks you have 2 $1 bills, is that a problem? Yep, that's a problem. Not good. Not good for bookkeeping. Could be interpreted as the number 2. Any other thoughts as to how it could be interpreted? That's actually the best answer for this. There is one other option of how it could be interpreted.
120.
We'll deal with that in part B, or part D, so we'll get back to that in a minute. If we aren't being careful, or if we try to put too many place value breaks in, it could possibly be interpreted like there's like a space between here. Visually think about it that way. And you could think that you have 1 60 and 1 1. So this would be the number 61. So there is the chance for that happening as well. But the bigger problem is the first one. That's the more likely thing that could be problematic, is that it could be interpreted as the number 2. Okay, so let's look at, you guys already said what the number should be if we were looking at the 2 triangle values. But let's look at the original value. The original value had a triangle, 5 arrows, and then 9 triangles, right? And I broke it up over here on purpose to look at the place values. So the first piece of this was in the 60s place. So that 1 is actually worth 60. So I have 1 60s. Actually, let me write this a little bit differently to show us our visual. We have 2 place values. This is the 60s place, this is the 1, and I have 1's place, and then I have 160. How many 1s did I have? Like how many are over here circled up right now? 59. There's 5 arrows worth 10 points each, that's 50. There's 9 triangles worth 1 point each, so 1 point each, worth 1 each, and that's 9. So we have 59. So there are 59 in the place value system on the far right. Okay, so there's 160, so we can take 1 times 60, plus 59 ones, so 59 times 1. This would actually be the number what? 119. We're just adding, right? 60 times 1 plus 59 times 1. That gives me 119. The original value, if we were looking at our system, at how much is this sort of worth, it would be worth what our digit is called as 119. And then you can actually look back at parts A and B and make sure that that makes sense to you as well. Does this digit right here on part B actually look like what we would call the number 120? Well, it is. I mean, how else would we write it? I mean, right? All we have are 2 symbols. What's actually the problem here? What's the problem with this one? There's nothing in the ones place, so there's not a placeholder, right? And we have one of those in our number system, don't we? What's our placeholder? It's a 0. So the biggest problem with this particular numeration system, as it is so far, is it misses that placeholder problem. I mean, we don't have a 0 to placehold anything. That's a problem. Okay? We also don't have anything that would prevent this. What if we really did have, this is a different problem, what if we really did have 160 and 1, 1? I mean, it would still look like triangle, triangle, right? Perhaps you could put enough space between them that people would understand that they're actually in different placeholders. But this number is the number 61. And it looks an awful lot like the number 2 and the number 120. So somehow it's like we need a comma or something, right? We need something that shows where we break things apart, and that's problematic for this number system as well. Agreed? Yeah. All right, we're going to take their number, one of our numbers now, the same number we saw before, and we're going to turn it into a Babylonian number. Okay, so this is a little bit trickier than with the Egyptians because they have this base 60 weirdness thing going on. They only have these 2 numerals, which are triangles and arrows, and it doesn't look the same at all. I mean, this is not simple and straightforward like with the Egyptians. So what are we going to do? Well, we've already discussed the fact that we have a place value that's 1s, a place value that's 60s, and a place value that's 60 squared, which we also would say is 3,600. What would happen if we tried to do 60 cubed? Can somebody tell me what we would get? Just what you get when you try that. It's big. $60 times 60 times 60. Yep, 216,000. I'm going to claim that's bigger than I need for this problem. How do I know that? It's larger than the 43,000 I have. So I don't need this one. I don't need this in my value system at all. Okay? So that's the first thing. All right, the next thing I'm going to do is I'm going to show you what your book calls, I don't know if they call it this, but it's the method they use. I'm going to call it the division scaffolding. Okay, so do you know what a scaffold is? Does anybody know? Can you describe it? What a scaffold is? Yeah, it's what you sort of would use to support the stuff, and it looks like, almost looks like you've got rungs of ladders and things like that, and extra wood and stuff like that going on. Well, we're going to scaffold, sort of build up what we're doing. So what we're going to do is we're going to take the biggest value that's of these place values, so these are my 3 place values, and I'm going to take the biggest one and I'm going to use it with division. So I'm going to have 3,600, and I'm going to do a division, and I'm going to put the number that I have given me, 43,205. And then here's where this is going to look a little bit different than division. I'm going to draw lines on either side so it looks like a top hat or something like that. Okay? So 3,600 goes on the left, and then the division answer is going to go here on the right. Okay, so grab your calculator for me. I just want you to do 43,205 divided by 3,600, and I want to know the whole number you get. Don't care about the decimals for the moment, just the whole number. 12. Fantastic. Okay, so Jessica got us a 12. Somebody else, I would like for you to multiply 12 times 3,600. What'd you get, Kaylee?
43,200.
Fantastic. Okay, that's almost the right value, isn't it? So if you think about what you do in our number system is then you would subtract, right? So we're going to subtract these. We're just doing long division. It just looks a little different. What do I get when I subtract?
5.
-5. And I'm going to draw this same top hat look around it. All right, so as we move forward, this is going to become more important than right now. But what we need to do next is to use the next place value, even if it's too big. Next place value, 60. How many times does 60 go into 5? 0, right? I mean, I know that seems sort of silly that we did that, but you'll see why more later on. So I want to be consistent. 0. What is 0 times 60? 0. That's good. And we subtract, we get the same beautiful number 5 that we had before. What's my next place value? It's a ones place. All right, so how many times does 1 go into 5? 5. What is 5 times 1? 5. And when I subtract, I get 0. In fact, I don't even need to draw that top hat. Yeah, now right here. Once I get 0, and I've divided by the smallest place value, which is always a 1. We always end with the number 1. I'm done. Now, I didn't answer the question quite yet. I found 12, 0, and 5. But what I need to do is I need to write the 12 like they would write a 12. How would they write a 12? Close. I think there's one arrow, right? Okay, so one arrow is worth 10, and each of my 2 triangles is worth 1. So this is the number 12. And then if they had a place value holder, we'd put a 0 next, but they don't, so we're just going to skip right over that. And the next thing we have is 5. How do they write a 5? They just do 5 triangles.
Do you want them to be a space like that when we do it?
It's a good question. So would they have had it? It seems unclear based on the things that I have looked at whether they would have had a space or not. So have a space, don't have a space? I don't know. Obviously, this is not such a great number because unless you put the space, and even if you put the space, there's nothing in there that indicated the 0 in the 60s placeholder, right? I mean, that's like weird. That's problematic. So if you take a look on this one, you could interpret this like this is supposed to be the number 43,205. But you could think that this is the number, even if there's a space, which is the best we could do, you could think that this is 12 60s plus 5 ones. And 12 60s plus 5 ones, I don't even have written down what that value is. 725, thank you. Or if there wasn't a space there or you didn't see the space distinctly enough, you could look at this and think that this is the number 17. So is it 725? Is it 17 or is it 43,205? This is not good, right? Not very good at all. So to answer, I think it was Caitlin that asked me the question, what should your answer look like? Well, some variation of this. Is there a space? Put it if you want to. Don't put it. It doesn't make any difference in terms of what I'm looking for in your answer.
On our homework and stuff, are there going to be times that we have to identify what that is?
Yes, but you're going to identify the best guess, which means that you're going to put the place values in as few times as possible.
Okay.
So like if you were looking at this and it didn't have the space, of course, because you were just looking at this written down, you would tell me that this number is 17. That's what you tell me.
Okay.
And of course, it was supposed to be 43,205, but you don't have any way of knowing that. So you would say it's going to be 17. All right, the Egyptians, the Babylonians, and now we have the Mayans. Oh, the Mayans. They messed up that calendar thing, right? Do you guys even know about that at this point? It's happened like several years ago. Nobody even knew. The world was supposed to end in 2012. What are we still doing here? I mean, really? Okay. They have 3 symbols. The dot is the first one. What do you think the dot might be worth? 1. Yeah, it is. All right, the next one, you're probably not going to guess right unless you've already looked at something about Mayans. The next one's actually worth 5. Okay, the line is worth 5. And the shell looks supposed to look kind of like a seashell. Okay, the shell is actually a 0. So we get a placeholder. Hey, that is a step up from the last one. Wouldn't you agree? I mean, at least if I had a placeholder between these 2 values, I would actually be able to get the 43,205. If I put a 0, plunked a 0 down in between where I've got that extra space going on, I would actually get 43,205. So this is definitely a plus. All right? They do have a place value system. Their place value system is a modified base 20, because it couldn't just be 20, right? That would be so simple. It would be simpler. Any guesses as to why the 20 might be happening? We'll talk about the modified in a minute. Any guesses as to the 20? What's that?
Big fingers and
Fingers and toes. Why might that make sense in a culture like the Mayans? Huh?
Or, like, they have more things to use in counting. It's not like they have more.
There's a practical sense of that too. Somebody else say something? I'm not sure on that. I'm not sure on that. Yeah, probably have to do with being barefoot, right? This whole idea of covering up our feet because it was cold and stuff like that, that's sort of a North American thing, definitely something that's not true for where they would have been residing, okay? So thinking barefoot, so they're going to see their toes a lot, okay? So this is something just sort of practically speaking. All right, let's talk about the modified business. Okay, so they have the place value system where they have 1 and then they have 20, okay? Now, let me talk about one more thing before I do this. It's written vertically. That's a little fun. Okay, so the ones place is on the bottom, and the higher that you go up is the higher place value. So like in our system, if this was what we did, we would write, the ones place and the tens place and the hundreds and the thousands. We just build up from there. And so our number, like 2,456 would look like 6,542. Okay, that's how it would look. Okay, so that's what they're going to do. They're going to build from the bottom up, smallest value on bottom, highest value on top. All right, so thinking and looking about that idea, modified base 20 system. So this place value is the ones place. The next, these are not supposed to be lines that are worth 5 points, okay? That's not what we're doing. I'm just giving you a place value holder for it. The next place is worth 20. The next place after this is worth 20. Instead of it being 20 squared, it's 20 times 18. I'll come back to that in just a second. After that, we have 20 squared times 18. And then we have 20 cubed times 18 and so forth, okay? So it's just this one weird 18 business going on in that third place value, and that sort of seems a little bit awkward. So grab your calculator, tell me what is 20 times 18, or in your head if you can, which is totally fine too. That is 360. So let's think about the number 360 and see if we can speculate why in the world they added so much to them to use an 18 there instead of another 20. Any guesses as to why 360 might have been special? There's a couple of thoughts. Degrees in a circle, 360 degrees in a circle. There's one more. Days of the year. So there's not exactly 360, but it's close, right? And those Mayans, they did that calendar thing, yeah? Yeah, so the 360 is coming most likely from that sort of a realm. Had to do with the days in a year stuff going on. Okay, it was something they get awfully close to. All right, so let me just write down a couple of these more just because it's going to be helpful for us later. Let's say, oops, hang on. What is the next one above from that? In fact, right here. What do I get if I do 20 times 20 times 18? Or if I did basically 360 times 20? What's the next value? So this is the 20s and the ones. What's up from that? 7,200 is correct. And we'll go just one higher because we shouldn't need to go any beyond that. What would the next one be? In other words, 7,200 times 20. I don't think that's quite right. I think it's 144,000, isn't it?
Yeah.
Okay. Which is an interesting scriptural number as well, isn't it? Interesting. Just saying, you guys know what 144,000 shows up in the Bible? Do you remember? Yeah, it's in Revelations. It's the redeemed after, supposedly the redeemed of Jewish, and we're not going to get into Revelation, but that's where it shows up, is in Revelation. Okay, we are going to take a look then at a numeral. Oh, one more thing, I didn't actually say it, it's on here of course, is that they write dots above bars. So like if you had the number 8, you'd have a 5, and you'd have 3 dots for the 3 ones. So this would be the number 8. So the dots go on top of the bars, okay? Dots on top of bars within a place value. Okay, so let's take a look at the first numeral in their system. You've got 2 dots and a line. You've got 4 dots, and you've got another line. And so this is kind of going back to what you were asking before, Caitlin, about the Babylonians. Where do I say the place value changes? Well, our goal is to have as few place value changes as possible. So when we look at this, the interpretation that we're going to make is that there is a place value change right here. Because dots should not be below lines unless they actually change places. So is that absolutely the only possibility? Well, no. I mean, like between the 4 dots and the line below, that could be 2 different place values. We don't have any way to distinguish it. Again, this is obviously a problem, right? the two dots on top in the line, could those be two different place values? Well, yeah, I mean, we don't have anything for sure that says it isn't, but our assumption is going to be simply the fewest place values that we need, okay? Are we all good with that? Okay. So if we think about it this way, there's two dots above and a line, and then there's four dots below and a line. Just for the sake of writing these down for the moment, what would be the value above the line, the blue line I've drawn? 7. And the value below would be a 9. So we'll interpret this in our number system in a moment. But what we're supposed to do right now is to figure out what comes before and after this place value. Okay, so just like with the other numeration systems, we look at the smallest place value to take that value and either add or subtract something to it, right? So the smallest place value. So that means, in this case, the lowest one. The lowest one on ours has these 4 dots in a line. We interpret it as the number 9. So what would I have to do if I wanted to get the number that comes before? Take away a dot, right? Okay, so the top part never changes on this. We still have the 2 dots and a line. That's the same. But instead of having 4 dots in a line, what we have? 3 dots and a line. Okay? What about if we wanted it to come after this numeral? Okay, so if we added a dot, we'd have 5 dots. 5 dots would be worth a line. So we still have the 2 dots and a line here, and now we have 2 more lines, which is obviously a problem, isn't it? I mean, this is right. We didn't make a mistake. We did it correctly. Who wants to do math in Mayan for a long period of time? Man, those would be really frustrating, I think, because now we have a problem. What other number could this number in part B represent? What do you think?
You could do like 144,002.
Okay, so you're thinking from the other perspective. Let me do the simplest. What's the simplest thing it could be? I think that's where you were headed at, Jessica. It could be 17. Do you see this number could be 17? That would be the simplest view of what this number could be. This number could be the number 17, right? It could all be one place value. There's nothing that distinguishes it. But we could also have the same problem, I think, which is what I think you were getting at, Madison, is kind of what we were talking about before, is that each one of these could be their own place value. Like this could be the 1's place, and this could be the 20's place, and this could be that 360's place, and this could be the 7200's place. Like we could have that, like legitimately, if we had values within those, that's what it would look like. So this would be an equally valuable problem to have, right? Not good. All right, we're going to actually find their value in our number system now. So let me take a look with you at the original value that we were looking at where we had the 7 and the 9, okay? So what we interpreted this to be is that we had the 20's place, and there was 7 in it, and we had the 1's place, and there was 9 in it, right? Okay, so just like with the Babylonians, what we do is we take the value that's in that place, 7, and multiply it by the value of that place, 20. Plus, we take the value in the place, 9, multiply by the value of the place, which is 1. So what is 7 times 20? 140 plus 9, so this is 149. So the problem would be that if we had the number 1 bigger, 150, it would end up looking like this bottom thing where we had 3 lines and 2 dots, and so somehow 150 looks just like 17 and a number of other problems, which is obviously a problem. All right, let's do one more the other direction. Just briefly, we'll just talk about it, and then we'll actually finish it last time. What we did before is we turned this into our number system by using that division scaffolding, right? Okay. Let's just figure out what those numbers were. So they were 1. Whoops, I'll write it vertically since they did. The 1's place, the 20's place. We had 360. What was next? 7,200, and then 144,000. Where can I stop? 7,200. I don't need the 144,000. Why not? It's too big. It's bigger than what I have. So when we come back next time, we're going to use these 4 values, and we're going to do that division scaffolding to turn this into our number. All right?